Greetings, let's say we, for example, want to take the square root of this big number, 103,041. And I'll say this one fact in a glance, and that is, by the way, this is also a perfect square. So when we take a square root of this, that will be still an integer, not a decimal. But I mean, this sort of algorithm that I'll be showing will also sort of work for decimal numbers, but just for this example, we'll be dealing with a nice example in the sense that there will be no decimal point to add, and there will be only an integer as a result as well. But the algorithm is very similar in the case of decimal number results. So let's proceed with it. The first step in the algorithm is to label the whole number in pairs. So it has 6 digits. We must go from the right side, and I'll underline every 2 digits going from the right. So the first 2 digits going from the right, the second two. There could also be an odd number of digits. Then we would still start from the right side, do 2, 2 until there is just 1. Because that if there's an odd number of digits in that number whose the square root of which we're taking, then we're gonna have pairs until there's just 1 digit left. And so then we'll just underline that 1 digit. But we must start from the right side. We go from the right side until we reach the left side. So in this case, it's 6 digits, so it's symmetrical. We have only the pairs. All right. So second step, and this is the first step in creating the result. This will directly generate the first number for the result. So first number of the number, which is the result of this square root. We'll be writing the result gradually above here. We will write it here, all right? Well, look from the left side on the first pair from the left side now. We labeled it from the right, but now we look at the first pair of digits from the left side of the number. We try to fit the biggest square in that number that's possible. That's smaller than the number, than the first pair. Well, the biggest square that is smaller than this most left pair is 3 times 3 times 3. 3 to the second power 9. And therefore, I'll write 3 right here. Alright, so the number whose square is the biggest possible number such that it's still smaller than the value of this 10 is going to be the first number of the result. So 3 squared is 9, still smaller than 10. 4 squared would already be bigger. I write down 3 as the first digit of the result. Then what we do next, I can write the 3 also here. And I'll also subtract, I'll be using space all around the place. It's not necessarily standardized, but we just have to keep track of the algorithm steps. But the next step is write it right here. This will become the first digit of the result. And that second power of that 3, all right, the number which we used to see, oh, is that 3 the first number? Yes, it is, because the second power is still smaller than the 10. We'll subtract from the 10. So we'll get 1. And to continue the algorithm, we take the second pair going from the left side, the next pair to the right of the first one, and add it there. Next step, and this is always the same, alright, so we're just describing the algorithm. Take the 3, which was that first digit we generated inside the result that we're waiting for, and double it. Or we just multiply by 2, and we can write it somewhere here, for example. We're just recording the numbers. It's not necessary to write it here or here. It's just a chosen system out of many different ways one can write it down, alright? What's important is that we write down the 6, and that 6 is a double of the first number we generated up here. We had 1 as a result of subtracting that 9 from this first pair, and we added precisely 1 more pair. And with that 6, what we will do is we will try to find some number, some integer, such that if we add it to this 6 to create a new number together with the 6, and we also multiply that whole number by that added thing, that result will be smaller or equal to that 130 we have here. So what number can that be? Alright, we put the same number here, and this is multiplication. So together with the 6, this is one number, but then this second digit will, the second part of the number beyond 6 will multiply this thing also. So what will work? Well, 60, and also another requirement here, choose such a number such that we maximize the size of this result, but it must be still smaller or equal to that 130. So which number is the biggest possible one to put here such that this still works out? So 0 is going to be 0, 61, well, if I choose 1, it's 61 times 1. That's still too small of a number. We can still increase it, perhaps. We can choose 2. 62 times 2 is 124. I choose 2. 124. Smaller or equal than 130. 3 would be already too big. That would exceed 63 times 3 would exceed this. So 2 is fine. And so that 2 we chose, we got, is going to be written here. Now that's the second digit of the result, of the final result. And now we will take this 124, 62 times 2, because that was smaller than 130. And I can keep it here so we remember what we were doing. And I will subtract it from the 130. So what I have is 6. And again, I will add, going to the right, the next pair of numbers from the original number. So 4, 1. And now I will take the whole 31, so the whole generated result, part of the whole so far part generated of the final result, and again multiply it by 2, just like we did to the 3 in the first, a few steps ago. So take the whole 32 now and multiply it by 2, and I will put it here perhaps. So I have 64. And now we'll do the same thing but with 64. So 64 and add what number times that same number in order to be smaller or equal to, again, the number that we have here, the last one so far in this chain. Well, that will be precisely 1, and of course the maximal one, the biggest one that we can use in this context. That works, because that's precisely 641. And we will end the algorithm here, because, again, I record that one right here. But we see if we, I said before that this is a perfect square, but we see there, if we now subtract the minus 641, we have a 0. And here the algorithm ends, and the 321 we got here is the result. So the square root of this number is 321. Alright? So there's many ways one can record the steps in the algorithm. And if we want to quickly go over it, the steps are roughly as follows. It's definitely better to perhaps run through the whole video again, because we talked it through more thoroughly. But to roughly repeat what the steps were. Take the argument of the root, go from the right side, underscore the pairs going from the right. Take the first pair, find what number taken to the second power is the biggest one that's still smaller than the 10. That's 3. Write it up here, that's going to be the first number of the result. Then from that 10, subtract that second power, that 9. You'll get 1. Also, take that 3 we created, multiply by 2 and write it here. So we will have it written down. Then add to this one that was a result of 10 minus 9. Add the second pair going to the right in the chain of pairs that the argument of the root contains. So 130. And then try to find some number that if we add it to the 6 and multiply again by that same number, it will be smaller or equal to that 130, but it will be the max option. So the biggest number that we can put here and multiply such that it's smaller than 130 or equal to it. But if we took one number higher than that, it would already surpass it. So that's going to be 2 in this case. So we write it as the second number of the result. And because 62 times 2 was this, we subtract it from the 140. We get as a result 6. And we go up here to the argument of the root and add that yet another pair, 641. Then we take that whole 32 that we had so far, at this point we only had 32, multiply by 2, and do the same thing with 64 now. And we find that 1 will fit exactly as equal to 641 we had here. And if we subtract from 641 we have 0 left. And here the algorithm ended. So now we got 1 here as well. That 1 was because it was contained in this 641. And so these 3 digits, 321, is the result of this square root.